Rob Giampietro is the design lead for Google's research and machine intelligence team in New York. From 2015 to 2017, he was creative lead for Google's Material Design Studio, managing projects that included 4-span design and technology conferences, the launch and relaunch of design.google.com, an overhaul of the Google Fonts directory, including significant new typeface commissions, and the ongoing expansion and development of the material design system itself. But though this image is rather enigmatic, Rob is no stranger to us himself. In addition to being a great friend of our program at SVA, Rob has been a senior critic in RISD's MFA graphic design program since 2006, and his writing about design has been published widely, from iMagazine to BusinessWeek to Google's own design site. From 2010 to 2015, he was a principal at Projects in New York, and with that firm was a recipient of a National Design Award. And I'm guessing he is the only person at Google to have won a Rome Prize. Is that true? And he was at the American Academy in Rome from 2014 to 2015. I have it on good authority that Rob is an avid pizza maker. Is that true, Rob? Sure. So I'm guessing that was the real reason he was in Rome. But without further ado, I welcome Rob Giampietro to the stage. Thank you.
Each talk that I've given here has kind of come at an interesting point in my career. So the first talk I gave actually was shortly after leaving my first studio, Giampietro and Smith. And I was in a kind of moving towards more kind of critical thinking in my own practice. And became very interested in this kind of idea of the consequences of design, or what happens when design kind of leaves the designer's hands and enters the world, and how we assess what it's doing there. And so this is just one slide drawn from that talk, which kind of was framed around this set of questions around, asking questions about how a design object enters the world and how we evaluate it, which is equally relevant now, in fact, even more so in terms of designing at scale at Google. And then the second talk I gave was part of a trio at Projects. We each kind of talked a little bit about our practices outside the studio. We had just opened an exhibition at the Art Institute of Chicago called Test Fit, in which we recurated the collection and made one-to-one kind of paper replicas of it in a gallery. And so we were all sort of thinking a lot about sort of practices outside of commissioned work. And I used this framework to talk a little bit about the design of writing. So writing that takes you there and then brings you back again, or writing that sort of loops you around and through a set of contexts and different things, and tried to sort of look at examples of that both in other writers' writing and in my own work. And in terms of this talk, there's so much to cover in any time you do this. It's actually the hardest part of giving a talk is editing. But in this talk, since I've talked a lot about kind of the bottom half of this list, I actually wanted to sort of focus a little bit more on the top half of this list. So talk a lot about work starting from my residency at the American Academy, and then going forward through Google, with a couple of things that have persisted since then. Line and Unline, which is really just my writing practice, and RISD, which is where I've been active for over a decade as a teacher in the MFA program. And in terms of my writing at the American Academy, it really fed my desire to understand and think carefully about the technologies that we live with every day. And so I wanted to open actually both with this image of my studio walls. In the American Academy, you get a beautiful studio, and you can kind of use it as your workshop over time. And when I first got there, it was sort of terrifying because I'd been doing commissioned work since I was 23, and suddenly didn't have a brief or any kind of deliverable, and had to kind of invent that myself. But you can see the map of Rome, and I would essentially go on walks every day and collect images, both images that I was making with my camera, with my mobile device, collect recordings, and also kind of these archival images, which started to kind of fall into these buckets and actually become a kind of slide talk / piece of writing that I'm still working on now. But what I wanted to do as a starting point was read you a little bit from that work. It's currently unpublished, but I just wanted to kind of give it as an opening thought. It's called Triangulation. And this picks up at a point in the essay is very long. It's about 30,000 words right now. Hopefully shorter than that someday. But there's a point where I'm reflecting on Morandi, and this section follows shortly after that. Morandi died in 1964 at home, where he had lived his entire life. He was at work on a new still life that is left untouched to this day. The same year, Massimo Vignelli worked with the plastic manufacturer Heller to create a line of colorful plastic nesting dinnerware. The publicity photos show them stacked and arranged in a way that pays tribute to Morandi's images. Vignelli would remain in Milan for 2 more years before leaving for New York. Along with Vignelli's stacks of Heller dinnerware, another set of images from Milan in 1964 showed a new set of children's chairs from the plastic manufacturer Cartel. Designed by Richard Sapper and Marco Zanuzzo, these stacked and nested as well, so a chair would become a stair, a chair would become a brick, a chair would become a molecule, and so on. Children would pile them up and climb inside, fascinated. By this time, Sapper and Zanuzzo had also been consulting for the electronics company Brian Vega for 5 years and released one of their most iconic designs for the company, the Radio Kubo TS502. Composed of 2 interlocking segments, the radio can be split into a glossy shell to reveal its interface, an AM tuner, FM tuner, and volume switch. The arcs and arches of these elements look almost like brows between the two panels when the body is split. The architect Carlo Scarpa, designing a majestic tomb for the radio's producer, Giuseppe Brian, and his wife used a similar motif, 2 circles crossing, Venn-like, to resolve 2 into 1. Holes in the wall, cast in concrete, ruins that see double and refuse to fully resolve. The tomb itself seems to cross necropolis and spacecraft. Like Elliot Noyes at IBM, like Dieter Rams at Braun, Ettore Satsas at Olivetti, and Jonathan Ive years later at Apple, Sapper and Zanuzzo excelled at making devices that were legible as bodies, with styled, polished, pristine exteriors that hinted at the complexities within. Sapper in particular would spend much of his career studying the joints and hinges that would allow devices to become mobile and portable. His 1967 landline handset for Siemens folded in half, anticipating Motorola's well-known StarTAC flip mobile phone decades later. His 1962 Doni television for Brian Vega had a translucent housing and a built-in handle like Ive's all-in-one iMac. Later, he would pioneer a clamshell laptop hinge for IBM's ThinkPad series. Quote, hinges are met with here and there and used in various ways before the 14th century, writes architectural historian Siegfried Gideon in his remarkable study, Mechanization Takes Command. One of the earliest records of foldable furniture, he notes, is, quote, a table that will fold into the wall like an ironing board, end quote, in Carpaccio's 1505 painting of St. Jerome in his study. Once the table was folded away, the room was free for Jerome to kneel in prayer. A powerful idea, this early example of the hinge in action. My earliest sense of the magic of hinges, before I could even read, may have been playing Enzo Mari's Fable game, a simple set of oversized cards, perfect for growing hands, with scenes printed on them. Slid together, they made worlds ripe for the childhood imagination. The lion gazed at the fox. The swan turned its back on the crow. And most of all, I had the exquisite pleasure of linking them together. If stories are made from characters, settings, and plot, designs are made from triangles, circles, and squares. And designers have been telling stories about these basic shapes for almost all of history. It's the story of the shape of an arch. From Pythagoras to Borromini, Dürer to El Lissitzky, each era spins its own tale from the same elements. Bruno Minari wrote 3 books, each in homage to the 3 basic shapes. Bradbury Thompson's Elements of Graphic Design features a meditation on them as well. Georgi Kepish's Language of Vision treats the basic shapes as axiomatic to all visual understanding. Designers Ellen Lupton and Abbott Miller write a modern history of these ideas in their book, The ABCs of Triangle, Circle, and Square. In the weeks after the shock of 9/11, I clung to Ellsworth Kelly's moving proposal that reduced the site to a simple green square periphery. It was geometry at its most powerful. Years later, I saw Saul Lewitt's early images of Manhattan with a triangle removed downtown, and my eyes slowly filled with tears at the sight. Perhaps inventing your own story about these shapes is an essential step in the story of a designer's life. You could go from having to take care of yourself and cultivate your own ideas to having to teach and take care of others. You make up tall tales based on what you've learned from those same familiar characters, the triangle, the circle, and the square. Like the graphic on Bradbury Thompson's cover, these images blend and overlap until they model a world of their own. Broader than any individual's vision, their merger makes a map, their significance a set of values, their relations a key. So that's just sort of part of a longer essay, but trying to kind of fit together ideas of classic graphic design reference with sort of ideas of technological innovation and how they could kind of be linked. And I think looking at that image of my studio earlier, I think this was a workshop that I gave at RISD just after I returned about the circuit and the form of the circuit. So I wrote about triangles and then returned to RISD and taught a course on circuits or circles. And used a similar technique with my students there to sort of iterate a book over the course of a very short period of time. So at this point, you might be asking yourself, wait a minute, what do you do at Google? And didn't mean to shock you too much there, but just wanted to sort of make sure that I introduced both sides of my practice. But I'm happy to talk a little bit about that, and actually very proud of the work that we've been doing at Google. And to sort of understand it, I think it's helpful to break it into some pieces. So I worked on a team called Google Design, and sort of loosely, this was our mission. It was really to help Google products and engage designers on behalf of Google in lots of different ways. And so, that might mean working to kind of take the updated identity and work to systematize it and give it a kind of structure, or work to evaluate that new identity for users around the world, users with low bandwidth and different types of needs. Or even to kind of think about the system in terms of its dynamism, so to think about how it works dynamically over time and changes from one form factor to another. So this is a set of flows for the Google Assistant. And once that work was sort of complete, we then worked to evangelize and explain our thinking there on Google Design, which launched a few months earlier. And then it was relaunched and sort of updated to kind of look more coherent with that new identity a couple months ago, actually. And one of our most popular articles is actually to take the material design system, which I'll talk about in a minute, and customize it for your own brand uses. It's called expressing brand in material. And so this is one of the examples that sort of deviates from the majority of the material design examples we show to customize it for a food app, a fake food app called Pesto. And if you look closely, we've started to do a lot of this with our own work at Google. So this is a recently relaunched Google Home app, and you can see here in the tab menu some of the Google colors starting to pop up in the selection states, and echoes of the Google logo with the headline typeface there. So just looking at different ways that you can take material design and kind of customize it for your own brand, in our case, for Google. Part of that work involved a really intensive amount of readability work on Google Sans, which is the primary typeface we use. So on the left is how it looked when we launched the new logo, and some of the kind of refreshed look at it now. And we also have a lot of materials that went with the digital aspects of the identity. So this is something we made when we sponsored the AGI conference in Bern, Switzerland. This was just sort of a graphic that celebrated both the modernist roots of that conference and also the new identity. And every year we try to take a lot of these physical artifacts that we produce and kind of gather them up and put them in kind of a VIP box to share out to lots of places. So SVA, I think, gets one every year, but a lot of other institutions do as well. And I think I'm a really big believer in beginner mind. So like when you first get somewhere and you really don't know anything, it can actually be very powerful. And one of my kind of beginner mind things at Google was, I was like, why doesn't Google Fonts look better? And like, why isn't it related to material, since material seems so interesting? And I mean, it turns out, you get there and a lot of people had that question. A lot of other people had that question as well. So within the first maybe 2 or 3 weeks of arriving at Google, I was approached by 2 folks from the Google Fonts team, Omer Ziv and Dave Crosland, and they really excitedly sat me down, and they were starting to talk, and I interrupted them, and I was like, what you should do? You should do this and this and this and this, and then they proceeded to show me a deck that basically said Google Fonts should do all of those exact things. So it was just very exciting to find people that I was so aligned with so early on. And we worked really closely together to take the product, the directory, which basically looked like this when we started, and apply all of the material design principles to it in order to sort of really reinvent it. And to something that I think really makes type the star and helps you distinguish between the type that you're looking at and the type that you're using as part of the interface. One of the biggest challenges we had to solve with this directory redesign project was actually the kind of ballooning size of the directory itself. So there are directories like the size of Monotype, which have thousands of fonts. There are kind of more bespoke font providers like Commercial Type, which may have many dozens of families that are tightly curated. But Google Fonts by 2016 had sprawled to about 804 typefaces, and it was really just hard to find the typeface you were looking for. So we did a huge amount of work behind the scenes, kind of scoring all of the different typefaces in the collection for quality, working to think about how different cultures describe these typefaces and looking for the best set of words to use to localize especially this side panel here, where you do your selection. We learned a lot about how people use this tool. They actually often come not just to find a single typeface, but often to find a couple typefaces that will solve the problem of what their blog should look like or what their brand should look like. So a lot of what was revealed in user testing was, hey, it's great you're helping me find one specific typeface, but that's not actually my problem. Once I have this typeface, I need to know which other typefaces go with it. So you start to actually have to do a certain amount of type education in order to teach people about pairing and other things like that. This is just sort of a recreation of what it was like to work on a very particular part of the interface. So this is when you add a font, Google Fonts is all free to use, but you add it and it kind of goes into like not a card exactly, but like a little area where you're hopefully going to get a single line of code that you can use to embed those fonts in your website. And one of the things we really want to help you do is both pick the fonts that you're really looking for and not use the ones that you're not, so it doesn't slow down your website, and in general optimize your website for fast loading. So there's a number of things that you have to do to kind of both pick the typefaces you want to use and then customize them for the exact character sets and other things that you need. So we had a lot of problems with this early on of just things like this little odometer, which is trying to visualize for you like the load time of your page and saying that it's kind of a little bit slow and pokey, but so many users just didn't understand what that meant. So even though the material design language gives you a certain range, like for things like the chips that are shown here, where you can remove those things, it's also it also needs to be pushed and extended. And in many ways, this is the kind of dialogue that goes on all the time at Google between the product teams and the material design team to sort of take the product team needs and adapt them into the larger system. And this is sort of our final example. We were able to reduce the number of steps from 3 to 2, give you the thing that you probably need the most, which is the embedding code, so that you can just go ahead and use this typeface right away, and a lot clearer on things like being able to download or share your collection with like a stakeholder or something like that. I think the other thing that I'm really proud of is just we realized that just like the material design system is kind of both a product and an education platform, this is also sort of an education product about teaching you who made this typeface and celebrating the art of type design, and also celebrating just the specification of the typeface and really taking a detailed look at it to make sure that it's right for you. So we actually did content strategy to write about all of these typefaces, and we did some collection work to put them into kind of collections, again, to make it easier to pick typefaces that would go well together. And it's obviously a great opportunity whenever you're relaunching a project to sort of do some things that will create new excitement and interest around it. And we had wanted to do a kind of material collection or typefaces with type designers that we really get excited about at Google. One of them was Colophon in the UK. They had been span speakers and were super excited about this idea of doing a kind of retro monospace, which we decided to call Space Mono. It kind of has overtones of computer interfaces from the 70s and 80s, things like the NASA worm and other types of unusual interface typefaces. And it's now in use on over 1 million websites, just only maybe a couple months after launch. So enormously popular, fun to see that kind of scale happen. And also, really fun to see it in use because we get to see how it's being used. And so this was a Kickstarter campaign by Gary Hustwit for a documentary about Dieter Rams that not only used it for the titling, but also for these beautiful letterpress posters of Rams's kind of core design principles. So there's no better compliment than that. Just to give, a really important part of working on a product is scale, and I think this is a huge adjustment or a change for me in going from kind of an agency practice like projects where we were doing a ton of commissioned work on behalf of clients to, where we weren't necessarily, the measurement of it was, did we serve the client well? Did the launch seem to go okay? But there weren't a ton of metrics related to that necessarily. But at Google, of course, that's a very, very important thing. We have a huge team mobilized to work on this project. Did we hit our mark or not? Google Fonts is actually one of our most used APIs at Google. So that gives you a sense of the kind of scale implicit within typography. And it creates a huge amount of expressive opportunity around the world. So even for things like Indic typefaces, there are online newspapers in India that rely on our fonts in order to simply communicate because we have some of the best Indic fonts available. What you're looking at here is a kind of a growth curve from when the project was launched in 2010 until 2016, shortly before we relaunched it. And that 15 billion marker is the number of fonts that are viewed per day on the by the catalog. So this is like, just people viewing the font on a daily basis 15 billion times. What it doesn't show is that that's cached. When you look at a Google font, it's actually cached in your browser for a year. So you don't have to go back and re-download it for another year. So that means 15 billion new views every day, which is a staggering amount. Just for context, the most popular YouTube video is 5 billion views in aggregate over its lifetime, which is Gangnam Style. So really staggering amount of scale in this product. And in terms of the lifetime views of the product, recently we passed 16 trillion font views in aggregate, which is just, like, I don't even know how to wrap my brain around that number. So you launch, and we sort of distinguish at Google between launches and landings. So we launch the product, yay, we have a big party. But then you have to kind of land the story of making sure that we're continuing to support the type design community and our users. And so one of the ways we're doing that is this program that really goes back and looks at those 800 fonts and says, are these best quality? What can we do to improve the quality? And in many cases, they were designed by students or by hobbyists. And so pairing professional type designers with those original makers to propose refinements and look at them together and fold those back into the library and improve it. The other thing is to expand the range. So when we relaunched the catalog, we greatly expanded the language support to 135 countries. And that's something that we continue to push on. Our base feature set is now required to cover more and more countries basically all the time. The other piece of the Google design mission is to engage designers in lots of different ways. This is just a still from a project I did with the London Design Museum. And we brought 13 artifacts from Google's design history to this show about design from California, including one of only 2 full-scale models of the Ladybug Waymo self-driving car prototype, and some things from the material design archives, like these papercraft light and shadow studies for some of our product icons. So really, really interesting. Justin McGurk, chief curator at the London Design Museum, was a SPAN speaker at our London conference. Dejin Sujuk spoke in Tokyo about Sony's design history. So we had great connection with the London Design Museum. And they involved a number of us early in this project to sort of make sure that they had their curatorial lens set well. And we really had a number of great dialogues with them about a design for technology and design from California. And the show is traveling, I believe, is now in Oslo and is traveling to one more site, which is not yet announced, but one more site after that. And I mentioned SPAN. SPAN is our annual conference about the intersection of design and technology. And when I arrived at Google, we had an earlier conference called Form, which brought a lot of people together in San Francisco to have these kind of discussions about the state of the industry and Google's relationship to that. When I arrived, we got a chance to sort of reboot it in London and New York, and really make it, I think, a little bit more about the best and most interesting thinkers and makers in the particular city that we were in. So since we were moving away from San Francisco, we were like, let's really celebrate New York, the startups in New York, the design thinkers in New York, and also give designers, if they're taking a whole day out, give them a chance to do things like they did a wonderful workshop with Tae-Yoon Choi, all about the handmade computer, so designers actually got to wire up a circuit board and just get their hands dirty with lots of different fun stuff. So this is, the other fun thing is that it really lets us put some of material design ideas into other contexts other than interfaces. So, what does it feel like to make a space as a design team at Google? What does it feel like to program a set of ideas or make an event or a broadcast or something like that? So this was just some of the graphics from New York. I hosted a few of the conferences, which was really, really fun. One of the things I'm most proud of is that we made this, we made this reader, which really was just, you do all this work, you get all of these amazing minds together for a single day, and then everybody goes away. And of course, as the person working on that for like 9 or 10 months, that's incredibly, it's incredibly sad. You wish you could bring those ideas together a little bit more. This book, I think, was really like the thing that we used as our Cliff's Notes as we were assembling the conference to sort of inspire us and remind us why we were inviting these folks. And we republished a lot of their writings and gave it to our guests. There may be copies here at Decrit. If there's not, please let me know, and I will get you guys some. Okay. So this is just a little bit of a look at the first year in 2015, and what that looked like. We took the system icons for material design, and we kind of blew them up and used them in a kind of unexpected way to tell stories about what our different speakers were speaking about. I think this is actually a talk that Paul gave here at SVA as a graduation address. So. And then the following year, Span went to LA and Tokyo, and so we had a slightly different look that year. Always this kind of massing of things to kind of suggest a grouping of ideas or a grouping of people or a set of things that are sort of similar but somewhat dissimilar at the same time. We really encourage kind of a mix of voices at Span. And these were designed with Chad Klopfer, wonderful, wonderful book designer who kind of came to the studio for a couple of months and did almost like a residency at Google with us to do these books. This one you could customize with some of these stickers that suggested everything from kind of flowchart gates to documents, icons, and even like sort of rising suns or different things like that. Again, some of the graphics inside. In Japan, we have been doing a really big push to make the material design guidelines more accessible in other parts of the world. So we released a set of PDFs that made them accessible in Japanese, which was a huge translation effort. And this was just the poster that we made to celebrate that. Some of the graphics inside the Los Angeles event. And these are some of the broadcast graphics that, as we live stream the event to thousands of people. So literally in the Japanese one, there are now subtitles, so you can kind of access the content in English or Japanese. And similarly, some of these, like while we're waiting to queue up another speaker or change rooms or something like that, just thinking about every aspect and touch point there. And this year we kind of both enlarged Span to 3 sites and kind of refocused it to Pittsburgh, which has a really unique story about design and technology really reshaping that city, but also a really interesting narrative about kind of urban renewal in America. And we paired that with other cities that had kind of similar narratives, Mexico City and Newcastle. So this is some of the graphics from that. So I mentioned there are these 2 sides to the material design team, one of which is this kind of helping Google and engaging designers on behalf of Google. The other side, working on a product, the material design product, expanding that system and crafting products that support it. And just to tell you a little bit about the story of that, in 2011, which is not that long ago, Gmail looked like this. So certainly full of functionality, lots of great features here, but not super useful. And ideas of aesthetics are somewhat variable across cultures, but I think we found that users were having a difficult time with this. And so Larry Page, our CEO at the time, got involved and basically asked the entire company to clean this up. And there was a joke that was essentially like doing that is going to be harder than landing a man on the moon. And so Project Kennedy was born, kind of in reference to that. And this is the output of Project Kennedy, which was really just to try to take some of these things and make them work a little bit better. And I think the key kind of moments here is just to sort of that there's a primary action there with a bright color, the compose button. That's probably the most important thing that you might want to do on this interface. There's a single taskbar at the top that makes the web app feel a little bit more like it's part of a larger system. And then there's just like better like spacing and typography overall that is makes it a little bit easier to use this interface. And when faced with something like making a baseline grid system for only their product or shipping an amazing new feature that users would love, typically the Gmail team would pick the latter rather than the former. So really the material design team exists to fulfill a very fundamental need, which is to build those features for all Google products so that individual product teams don't bear the brunt of that need. So we got really serious about this after Kennedy and decided to do a lot more, particularly for mobile and touch interfaces. And what you saw here is how Android evolved over about 3 or 4 years from that early interface to the material design system that we have now. Again, colored app bars that help you know when you're switching between tasks, which app you're in, floating action buttons, these sort of large circular buttons, much better typography, and just sort of a clear, consistent design language across everything. To do that, you have to make it really easy to follow the system. So this is one of the tools we use within Google, but these are also available on the Material Design website. This is a Material Design sticker sheet. And you can sort of see how some of these components get nested together. So there we have in the middle there we have a set of system icons, but then you can see within the app header here how those system icons start to get folded into the app header in a kind of consistent way. Those icons are actually one of the most popular outputs of the material design system. They're open source. They're available on GitHub and through many other ways. But essentially, the GitHub repository is like one of the most starred on GitHub. I think it's been starred like 28,000 times or something really crazy. The other thing that's really important is if you're creating a design system that works across a lot of different devices, you need a way to create some consistency across all of those different viewport sizes and screen sizes. And so the density-independent pixel was the method that material design embraced for doing that. Once you have that kind of basic unit, you can do a lot more sophisticated specifications. So all of our design, this won't be unfamiliar to any UI designer, but is carefully redlined so that it can be built by an engineer. And then once that component is built, it can be reused in Google products and in third-party products as well. This is some of the stuff that I got really excited about, like beyond just sort of like the flat graphic design or visual design of the interfaces. The kind of interaction models of these interfaces is also really sophisticated and beautiful. So when you have something like an interface with lots of different panels and things that slide on top of each other, you need a kind of elevation model to help the user understand what's in front and what's behind and what's on top and what slides away. And so this is the sort of master elevation model that includes things like modal layers that appear on top of your. And every time you introduce one of these layers, you add complexity to the user's kind of mental model of what they're doing. So you really want to purposefully limit how much elevation can be accrued by the system. So I think material design does a very elegant job of that. And these are all variable per app. So you might have an app that wants to be less layered, that wants to feel super simple and flat, or an app that's more layered to kind of really generously give people a sense of what they're doing at a particular moment. This is just a little bit of a deeper dive into like how that gets translated. And again. And finally, we use this tool called vignettes to just sort of show how, when the system is applied properly, how it all comes together. Not showing any specific product, but rather a fictional product that just kind of inspires people, hopefully, to take this and do this themselves. So if you're interested in this, it's an amazing tool, especially if you're just getting into interaction design. Has almost every interaction pattern in there with Google research and amazing best practices behind it. Material.io is a place where you can go and get it all. And then about a couple months ago, I got an opportunity to join a new team at Google that was sort of growing and needing a site lead in New York. And that team was within the Google Research and Machine Intelligence org. And obviously, I really love the material team. It's an incredible team. I'm a user. But at the same time, when you get the opportunity to work on something that's really sort of generation-defining like AI at a place like Google with some of our best scientists and engineers, it's hard to say no. So I said yes and joined the RMI team. And it's been an incredible learning experience thus far. And what I wanted to do kind of for the second part of this talk is just to sort of give you the broad strokes of what machine intelligence and machine learning is. A lot of you may be familiar with it, but I just want to sort of give you a little bit of a sense of how we think about it at Google and a little bit of how our team is applying it in some of our products. And this has been a journey that I've been on myself, just so a lot of this is sort of fresh from my own learning over the last couple of months. And so I think it's really natural to ask kind of like, what is machine intelligence? Artificial intelligence is a really broad term. It's in some ways, it's, I think, very overused. But what is machine intelligence? And really, if you just think about it, machine intelligence or artificial intelligence is just automating a decision-making process. So it's taking something that you would have to decide, and it's automating it. It's kind of tempting to think about that as like sort of a robot on the assembly line, like automating a process. But you could equally think about it as a door that has a camera that recognizes when you come near it and then opens up. Or even more, like a toaster that senses that it gets to a certain temperature and then like pops up the toast so that you don't have to go over there and check on it. So, machine intelligence is really, in some ways, this is that. So it's easy to make it really complicated, but it can actually be at its core very simple. And I would differentiate it from something like artificial general intelligence, which is really the attempt to sort of make a human mind out of a computer, which I think some of us would even ask, like, is that even something we should do? But I think that machine intelligence is more narrowly defined. But beyond that, we work very much on machine learning, which is an even narrower kind of part of that spectrum. If you think about typical types of programming, you're programming a kind of a set of decisions that kind of happen in an order. With machine learning, you're not doing that manual coding of like, do this, then this, then this. Oh, if no, then go this and do that. It's not that kind of instruction. Instead, the decisions that the system makes are learned based on lots of different data. So essentially, it analyzes that data, kind of makes a model from it, and then sort of when you ask it a question, it tells you what it's learned about that data. And I think this is primarily helpful when you're making predictions. So this is like a lot of the use cases for machine learning right now are around prediction. And so it's natural to ask kind of like, what are we trying to predict? It might be things like the next item in a sequence, the relationships between things, and also alongside those predictions, how confident are we in those predictions? So is this a pretty good prediction or kind of like just a so-so prediction? And so, again, just sort of talking about what machine learning can predict. Here it is predicting, like, is this a face? Like, well, I know I've taken some points, I've mapped the relationships to one another, and I can say with high or low confidence whether or not this is a face. Or image recognition, just even more kind of more granular than that. Like, what do I think this is? Is this a person? Is this a kite? I see the ocean. I see the sky. I know that kites are in the sky. So some of this entity and image recognition. Translation, so predicting what a word is in another language. So I have a high degree of confidence that this phrase in Chinese sort of maps over. Predicting if something is from a human or not, if it's spam. Predicting what you might want to watch next on YouTube. So recommendation engines and things like that. So predictions are everywhere when you think about a typical user experience. The next thing I want to say is, like, if you've ever taught anyone something, especially a child, then you're probably already an expert at machine learning, because really what we're trying to do is break down a task into very fundamental parts, teach those parts, and then like reinforce them so that they can be kind of reused by the learner. So early childhood education actually has a lot to teach us about developing good machine learning. Basically, I want to get a little bit into the details of how this works and how this process works in the next set of slides. So if we think about how ML works, a good working definition is that it uses models to use features to generate predictions from training. So there's a couple different words in there. Let me like unpack them. Let's talk a little bit about what features are, a little bit about what predictions are, and a little bit about what training is. So features are really simple. Features are just details about data that can be expressed by a number. So latitude and longitude, the address or phone number of this business, its average score, like anything that can be expressed as a number, even color values on the screen. Anything that can be expressed as a number is a feature of this data. And so again, like to use facial recognition, the distances between a set of points, or even on roads, like a feature might be how many lanes that road has and whether it's single directional or bidirectional or something like that. So then predictions are essentially a 0 to n value usually 0 to 1, that give a kind of confidence score. So basically saying like, I'm 95% confident that you will like this Netflix movie, right? So that's a prediction. And they fall into kind of 3 types. One is classification, so it's just predicting if something belongs in a certain category. So I'm pretty sure this is a table, and it belongs in the table category. Another type of prediction is regression. So essentially, are a set of values converging on a single numerical value? And so if we can see that pattern happening, then we've kind of reached a regression pattern. So really useful for predicting when a restaurant is busy on Google Maps, for example. We see lots of people asking about whether this restaurant is open or not at this time of day. They seem to be using their Google Maps to navigate there. Therefore, we can tell you at 3 p.m. that you probably won't get a seat or something like that. And then I think the other really interesting type of prediction is clustering, which is just talking about how good of friends are these 2 pieces of data? How related are they? And what I'm showing here on the left is a canonical data set that's used in image recognition called MNIST, and it's basically many thousands of handwritten numbers. Right? And you can see how this would be really useful to a bank or someone that's like writing, that's trying to do text recognition on someone writing a check and writing in the amount on the check or something like that. But like this 5 is like pretty different from that 5. If we went pixel by pixel and we asked the computer, is this the same as this? It would be pretty hard for it to do that based on purely on the image data alone. So what you have to do is train it on lots of different data, and then use different types of visualizations to sort of understand what the machine can see in this data. And so what you're looking at here is a particular type of visualization called T-SNE, T stochastic nearest neighbor embedding. But it takes a lot of different facets of this data. So we might know, like, OK, it's got this thickness of stroke. It has this many edges. It has this much curliness on this particular aspect of the 5. And each one of those things is a feature of the individual thing. And then as you aggregate those features, you get a high-dimensional understanding. Each one of those features is a dimension of this. You get a high-dimensional understanding of this particular piece of data. And in order to relate those things in high-dimensional space, you need lots of, just like a globe to a map, kind of flattens out certain things and distorts other things. You need lots of different types of visualizations to understand those relationships. So T-SNE does a particularly good job of clustering these things. And you can see here how these different MNIST numbers are clustering together in this space. So the machine has learned something about these numbers. But it's still making some mistakes. So that 8 and that 5 are kind of like so close that it's a little bit confused. It doesn't have a high degree of confidence about those two things. So if you want to play with this, I actually would highly recommend it. It's really fun. You can go to projector.tensorflow.com. They have a lot of samples, data sets there. And you can actually look at different visualizations and understand how they work. Another type of prediction is sequencing. So what comes next in a sequence? And this is used for swipe typing. Used for many things, but swipe typing is a particularly good one. It's also used for autocomplete. Like within this sentence is a sequence of words. What word probably comes next? So anytime you're typing on your keyboard and it knows which word is next, sequencing prediction is working as it should. And then the last word in that kind of trio of magenta words that I highlighted before is training. And I wanted to talk a little bit about what that means. So one common type of training is supervised learning. And essentially, what this means is that we take a bunch of data, we label what we care about the model learning, and then we test to see if the model learned the right thing. So this is something we launched recently called Teachable Machine. This is another AI experiment that you can play with. And essentially what she's doing here is she's using her web camera. It's got a very coarse resolution model. And when her face appears, the machine shows it's been trained on a certain number of examples of frames from this little interaction. When she appears, the confidence changes and it plays a sound. So this is exactly how those remote doors open, right? It's like it sees you, it has a high degree of confidence that a person is near, and the doors open up. So Teachable Machine is essentially like a very, very simple AI that you can play with. And what you do is you push a button to say, like, right now I'm standing in the middle of the camera, and then you push another button to say, right now I'm standing off camera, and you're essentially teaching or supervising the machine learning the right things about the webcam's image at that moment. So you're training it. So just to kind of break down some of these different terms, the data is labeled. We give it a label. A labeler is what's called a rater in machine learning terms. So there are all these people that are rating data. The training data is the result. So after we've gotten all sorts of ratings here, we then have the training data. And we call something ground truth if a human said that that is accurate. So if I call a business and I say, is this your address? The ground truth is the human being saying, yes, that is my accurate address. Or is this the color red? Yes, that's red, ground truth. So basically, human beings are still validating, in a supervised machine learning model, lots and lots of data around that. And I think this is one other kind of really important part of sort of seeing whether that ground truth and how the model's doing against that ground truth. This is what's called a confusion matrix. And you can see that essentially there's the reference, the ground truth, and there's the prediction that's output by the model. And it could be, either one could be either true or false. And so, a true positive would be, I searched for a playground and I got a playground in my photo. So basically, I said I wanted a playground, and the ground truth, it was labeled accurately, I got a playground back. A true negative is I didn't want spam and I didn't get spam. So basically said no to something, didn't get it. A false positive is I searched for a baby and I got a baby seal. So it's basically it was sort of not, it gave me something back that it was confident was the right thing, but it wasn't the right thing. And you can see how this could be really, really bad for users. For example, in things like adult education content being surfaced to kids by through certain keywords or something like that. You can see how these kinds of false positives are really something we look hard at before we release models. The other one is a false negative, something like I didn't want spam, but I got spam. Okay, so basically you can see that there's some crunchiness on this confusion matrix, but this is how all of the kind of data is evaluated. Another type of training is unsupervised training. So this is kind of a magic thing where you show a computer lots of data, you don't have that data labeled, and you just let the model start to make inferences on its own or cluster these things on its own. And what this means is that there may often be words that we as humans can't really think of or describe to label the data, but the computer has found some kind of aspect of that data that allows meaning, a meaning that we have and we share with it to emerge. So what you're seeing right now is a machine learning model performing sentiment analysis on an Amazon review. And essentially, it's saying whether green being a positive aspect of the review, red being a negative aspect of the review. So it's basically saying, I think that this, where he's saying the absolute worst disparity between novel and screen adaptation, I think this is a negative sentence. But we don't exactly know how to describe what is negative about that. We know that that's negative, but we don't exactly know how to tell a computer to label that. So, but when we get it back, we get back the right thing. So the model is solid. And then the last type of training is reinforcement training. And this is really handy for anything that's happening in time. So essentially, a self-driving car is a great example of reinforcement learning, as is game playing, where you take turns and essentially the environment is constantly changing over the course of the game. And so the model has to keep reevaluating what it will do. And so this is a really new part of machine learning that is being pioneered in many ways by DeepMind at Google. It's how the AlphaGo model works, as well as, again, a lot of algorithms in our self-driving car. So we've learned a little bit about some basic concepts about machine learning, and I want to just take a couple of minutes to debunk some myths. So Molly Wright Steenson has a great new book out all about kind of early ideas about AI in architecture. And she gave a talk at Span Pittsburgh, which you can watch online. But I think she started her talk by showing images of these kind of folk images of what is an AI. And AI is a robot. It's a brain in the cloud that rains down data. AI is blue and somehow kind of inhuman. And I think we need to be really mindful of these cultural perceptions about AI and try to be precise by what we mean with these terms. We've learned that machine learning is a subset of AI, but they're not the same. we've also learned that like machine learning is not like a monolithic thing. It's usually like a feature or an aspect of an app. It usually enhances the quality of the use of the app, but it's not like someone's like, this is a whole new machine learning word processor. Because in a certain sense, that might be an aspect or a feature of that thing, but you can't write it soup to nuts with machine learning. That would be crazy to try to use something like that. I think this is really important, particularly to my team, and I'll talk about this a little bit more in a second, but machine learning is not cloud only. So it's not always happening in the cloud. In fact, increasingly it's happening on your device. And if you think about something like the keyboard on your mobile phone, a keyboard is actually learning how you type, learning the kinds of words you use, and predicting them. And oftentimes it's doing that locally. So if you use the Apple keyboard, it uses something called differential privacy to do this. Our own Gboard app also doesn't require you to log into your Google account. So it's learning locally on device, and it's keeping that information on device and not pushing it up to the cloud. Machine learning also requires human review at all stages. It's hard to, in most cases, it's hard to teach a computer very much if you don't have human being reviewing whether that stuff is any good. It's not neutral. It reflects our own biases all the time. So if we mislabel data based on our own biases, or we don't have a diverse set of raters on that data, then often those biases will transfer to the data set and be amplified by the model. So we have to be very careful about those kinds of things. And it's not perfect. As you can see, there's lots of errors and mistakes. So it's used best as a kind of heuristic rather than as a kind of definitive final product. And so I think for all of these faults, and I think this is where policy and leadership come in. And these are a few things that have been recently recommended by AI Now, which is a new institute at NYU that's studying the effects of AI on society. Our own Meredith Whitaker at Google, who's a colleague of mine, is one of the co-founders of AI Now. The other co-founder, Kate Crawford, formerly of Microsoft Research. And these are some of their recommendations from their latest report, which you can read, and is really fascinating. One of which is that ML results should be legible. So we see this all the time. It's like it should not be a black box. We need to be able to understand what's coming out of the model. They should be tested and monitored for bias for all the reasons that I just explained. Data sets need to be reviewed and adjusted. So is this data set helping us get clearer answers? And if not, should we go back and revisit it and retrain the model? And also, almost like the ingredients of your food are something that you care a lot about and get active about as someone who eats food. The data that the model that you're using has been trained on is also something that should be transparent and accessible to you to some degree. Machine learning reviewers should not only be technical, so we need sociologists, we need also non-technical reviewers, artists, and other people to review, policymakers to do this. Machine learning development should be diverse, so it can't just be one subset of the population developing machine learning. We need a diverse set of people making machine learning and adding to the field in order for it to be really reflective of all of us. Ethics should have oversight and accountability, as in any field. And I think really important to me is that it's human-centered, just meaning that if we shouldn't just add it to be magical. We should make sure that it's actually enhancing the quality of our lives. And we really need to ask a lot of questions about are these features human-centered, and are they adding to that? So again, I encourage you to check that out. You can also check out this talk from my colleagues Jess Holbrook and Josh Lovejoy, all about human-centered machine learning. They recently gave a talk at Google. And Fernanda Viegas and Martin Wattenberg, the co-founders of PAIR, People in AI Research, data scientists at Google. They did the T-SNE visualization that you saw, incredible data visualizers and leaders in the field here. And in terms of how some of these things, if we get them right, could transform society, this is the Jigsaw Perspective API. It looks at it was trained on thousands and thousands of comments from the New York Times website, and raters rated those in terms of toxicity, and the model then, similar to the sentiment analysis model, began to learn what a toxic comment looks like, and made it much, much easier for moderators of article comment threads to be able to moderate at scale. So essentially, this takes away toxic dialogue from the debate and allows sort of more meaningful dialogue to happen, which I think is really cool. And then just to run through a couple examples from my team, and then I promise I'll end this and invite your questions. We don't just look at kind of the ethics and also products, but we also try to think about the creative applications of machine learning in my team. So there's an initiative called AMI, or Artisan Machine Intelligence, that really got started when this image called Trippy Squirrel was leaked onto a message board, a Reddit message thread, and people were like, what the hell is this? And essentially, we had taken a machine learning model that had been trained to recognize dogs and asked that model to look at this picture of a squirrel and hallucinate a dog into it. So essentially, you run that model in reverse, and the machine learning model starts to see dogs where there are no dogs. And it starts to try to push pixels around to make dogs appear so that it's more confident that dogs are there. And so you can get some really trippy things out of this. But you can also do some really beautiful art projects. So we partnered with an artist named Rafik Anadol and Mike Taika, who's an artist and scientist in my team. And they essentially showed a machine learning model thousands and thousands of documents from an archive in Istanbul, and then asked the model to hallucinate documents that never existed in that archive. So essentially, this is a fantasy archive in this kind of infinite mirror room, and you can use an iPad to kind of infinitely navigate the space, and kind of it never ends. It's like a never-ending archive. Another thing that's quite interesting right now, and there's a lot of great online demos about this, is something called generative adversarial networks. So essentially, an adversarial network is where you have two machine learning models kind of bolted together. One is trying to make a picture of a human face, and the other one is trying to say, I don't think this is a real human face, or I think this is a real human face. So they're adversaries. One is there to generate things, and the other one there is called BS. And then that makes the first one get better and better, and the next one get better and better in spotting the fake. And they essentially reinforce each other over time so that you can generate portraits of people that never existed. So this is trained on many thousands of Flickr images, but then through an adversarial network, essentially inventing a new person out of that training data. And there are now experiments from NVIDIA, who build some of the best graphics chips in the industry, showing an hour of hallucinated celebrities. So you can basically look at an hour of celebrities that never existed, but they look like they should be celebrities because they've been trained on a model of celebrities. It's not just image applications that we use. So there's something called a long-term, short-term network, where you ask a network to store lots of data in its memory bank, a corpus of words and their relationships, and then it can output in a short-term way new sentences and things like that. So Ross Goodwin, an artist, drove a car with a kind of closed-circuit TV camera and Foursquare data being piped in and geolocation data being piped in. And essentially, the machine learning model described what it saw on the road based on this kind of long-term, short-term model that had been trained on poetry. So it's a sort of like Jack Kerouac-like word car that drove to New Orleans. And there's a great little travelogue that was written about this. And then finally, kind of in terms of actual products, and I'll close here, my team concentrates specifically on on-device intelligence. So I drew that distinction earlier between the cloud and things that are happening on device. We're very, very interested in the intersection between hardware, software, and AI. And again, that has great implications for privacy. We're very focused on use cases that augment the user rather than automate. So we want to be able to extend your own capacities rather than replace them. And then finally, because we're working on device and using device sensors, we're very, very interested in sensing for context. So if you get lots of sense data, the same way with self-driving car, it's getting tons of different data, radar, LiDAR data, image data, speed data, all types of other things, geolocation. It can sense the context and make the right decision to keep the driver safe or the passengers safe. And so essentially, this is the same idea for phones and other devices. So one of the things we launched in October was Google Lens. This is using lots of different computer vision models to recognize things that are in the viewfinder. Another thing that we launched is the Clips camera. So this is a really interesting camera that recognizes children and pets in your life. You teach it, you essentially train it to notice certain pets and children or different things. It takes pictures of what you've taught it to recognize. All of those are stored on device. And you're able to view them through your phone, through a local connection, and then decide which ones you think are good and push those to the cloud if you wish. But all of it is completely private. And essentially, it helps you stay in the moment. It's a really interesting new take on kind of a GoPro form factor. Another really interesting application of machine learning in this space is now playing. So we've trained a model to hear OK Google and then wake up a device sensors and do natural language processing and speech recognition. We also know if something's music or not. So what if the computer could wake up if it thinks it hears music? And then we have 70,000 fingerprints of songs, so very, very small bits of data about 70,000 songs that get stored on the pixel. And if it can recognize or match the song it hears, it tells you. So it's sort of a magical little thing. It works in airplane mode. And if you want to know more about the song, you can tap it, and it will give you a handoff to the assistant where you can listen to it. So just this kind of really interesting, uses your own tastes in music as well as things like popular songs right now and things like that. The Gboard uses both glide typing. I talked a little bit about sequencing and that, but also something called federated learning. So this is where obviously none of us want every keystroke we type going up to the cloud. That would be weird. So how do we train a model to get better, and how do we anonymize that data? And essentially, we push a model down to you, download it. You use it for a while. We see how good it was compared to the last model. And then it's only the success or failure of that new model around certain parameters that gets pushed back up, but none of the data. And all of it is federated or shared across a federation of phones so that it's anonymized. So essentially, this is a much better way of training locally on device and improving those models over time. And then finally, I got to work on a really fun project this year called AIY, which is essentially not just having us make all the hardware and give it to you, but having you try making the hardware and training it and wiring it up yourself. So this is democratizing Google's AI, making the price point very, very low. This is a $35 Google Home in a cardboard box. It uses all the same chipsets and training models, and we just released essentially a cardboard version of the Clips camera as well. And this works exactly the same way locally on device, but is far more hackable and has some next generation chipsets and stuff in it as well. So I'll stop there. Thanks, you've been really patient. I'm happy to take your questions as well. So.